Hey everyone, it's time for a November update. So here's a list of new things that are done. Before I go in order though, I want to show you a couple things right out of the gate. We now have the ability to render text onto the screen as well as a clock that we make with that text. So let me run this. So it flashes the Kitsune name under the logo now, and it kind of does it in an animated way. And we have to use the clock on the chip in order to make it spaced out like that properly. And then, of course, up here you see we're using that same clock to drive an uptime timer. This isn't an actual clock, but it just shows the seconds, minutes, and hours that you've been running the Pi. So let me zoom this down a bit, and we can go over some other stuff. Starting at the bottom, I showed you that you can read coprocessors last time. Well, now you can write coprocessors. So you'll notice that this is new. So by default, whenever you're running it, it's going to be off of the system control register. And you can hit, you see they're all 0 right now. So we're going to read in these bits. And now you can see which ones are set. They're pretty much all 0 except for this one. And these are the labels of each bit for this register. So if I click on these, you can see what these bits actually do. So I can click M, and it's like, oh, this is the MMU enable bit. And it shows you what the values mean. So I can either click here to toggle that on or off, or I can click here to do that as well. And then you can even see up here, it'll change this value. So let's say I turn it on. If I hit right, that'll switch on the MMU, which will brick it right now because I don't have MMU set up properly. But what we could do is set up cache. I tried to see if caching would make the frame buffer write faster. It didn't seem to affect it, so I just left that out. But yeah, if I hit right now, that would enable the cache. I don't think it'll break anything, so I'll just set it. And yeah, so this is really convenient. I haven't written the definition files for all the registers, but I've done a few of them. For example, another one I've done is, let's see, it's this one. Oh, one more. This one. This register, IDPFRO, I forget what that stands for, but there's basically, when you see these arrows, this means these 4 bits are in a group. So if I click this, this will say, oh, I have to read this. There we go. That was the old state in there. So you see we've got 1, 3, 1, and 1. So for these bits, this indicates whether or not ARM instructions are supported, and this one says yes, it is. And this is read only. You can see the writes disabled. This group, state 1, and this can all be found in the ARM documentation for the ARM 7 architecture. State 1, this one actually has more than just a Boolean value. This one actually has 3 values for thumb instruction support, not implemented, encodings before, thumb 2, reserved, and then full thumb. And then this one is Giselle extension support, which is the ability to run Java bytecode on the chip. And then this one is thumb EE. So the other ones don't really have this set. Like if I pull up this one, it's just, I hit read. Let's see, that one doesn't have anything on it. Let's see, VBAR, yeah. This one doesn't have support for it yet. If you want to, you can go in here under the tools, you go to serial client, and you go to data. No, is it data? No, where did I put this? Common. I think it's under common. Here we go, coprocs. So yeah, you write these coprocs files, and this is all just pulled from the ARM architecture reference. So this is the PFR0 register, and then you've got the system control register. That one has quite a lot of them. So yeah, and it'll even show you like these ones here. This one means should always B1 should always be 0. So I've just disabled those, and that's in the spec as well. So these other ones, you can just kind of click on them and be like, oh, branch prediction enable, instruction cache enable. So yeah, I found this really helpful when I was playing around with the cache and trying to figure out if that would help speed up the performance, but it didn't. I think I have to turn on cache and MMU for it to get any performance bonuses out of that. All right, let's move on to the next one. Yeah, this was enable the cache to see if the clear function runs faster. It doesn't. I created a new binary protocol between the serial client and Kitsune OS. This is kind of hard to show off, but essentially what it does is behind the scenes, I used to just send like raw bytes back and forth, but now there's actually a protocol that it'll talk back and forth, and that way I can actually send data in a way that's a little more controlled. I might do a separate video on that because it's a little more complicated. As well, oh yeah, I made a new component where you can read the control current status program. Oh, that's backwards. That should be current program status register. The CPSR bits. So that's not, these are all coprocessors that use this particular instruction. This current program status register uses a different instruction to get that. So I have it on a different tab. You can read it. And again, we have all of our definitions here. So this is after you do operations, these will update the carry flag, overflow, stuff like that. And then you've got really important, useful ones over here, like you can mask abort exceptions, IRQ exceptions, fast IRQ exceptions. And then this is your mode. This is pretty important. This kind of determines what quote-unquote ring level you're in. So user would be the very, basic. This is where most programs run in. And then this is where your OS runs, and then you have all these different modes. So like when you get one of your interrupts triggers, it'll be in this mode. So you can set those directly here if you want to. It'll probably brick it, but this just kind of helps. If nothing else, it just gives you insight as, I'm right now in supervisor mode. So yeah, that's nice. I like that. And in the future, I'll be able to, really, I wanted this for these two because I want to be able to, when I'm playing around with certain interrupts, I'll want to be able to manually flip those on and off for troubleshooting. All right. Oh, okay. So whenever you draw this curve here, it's always been orange. I now added a little color picker, so now you can pick the color. So by default, it just draws orange. You see, it just drew over the logo. Or you can have like a nice blue color. Oh, that's nice. You get green, lime color, or you could just pick some really odd color yourself. It's got a transparency slider, but transparency is not supported. See, it just draws the same color. Let's see. Let's go with a nice kind of dark cyan color. There we go. And then you can always just put it back to its normal, nice fox orange color right there. So just like a fun little cosmetic thing. There's now support for building in Docker. So if you don't want to have to download and install all of the cross compilers, I've got some instructions here in the README file. In fact, let's pull it open in the browser. Let's see here. Compiling the kernel in Docker. So all you have to do now is install Docker and run these two commands, and it'll actually build the kernel in your project directory. It mounts the directory into Docker, builds it, and so you don't have to worry about installing ImageMagick or the ARM cross compiler if you don't have it. So that's kind of handy for people who just want to develop but don't want to have to mess around with tools. I made the frame buffer clear and draw image functions a lot faster. It's kind of hard to tell in the emulator just because it's so fast to begin with, but if you're running this on actual hardware, drawing stuff would be kind of slow, especially like clearing the frame buffer. It used to take like a second or two. Now it happens within, I think a 60th or 1/30th of a second. So it's super quick now. Although this little band here, if you're drawing on actual hardware, will still take a long time. That one's not optimized because it's not an image, so that's still slow. So yeah, this one. This has actually been in the OS for a while, but I just haven't shown it. But I figure why not? We'll show it off. Kitsune OS now has a mascot. We'll make this a little bit bigger. I hired someone to draw a little commission art. So, boom, little fun anime mascot there. And she's even got a little logo in her hair. I had a great artist do this for me. His name is Glorian online. Ordered off Etsy, Gloristic Art. There he is right there. Great stuff. You can see he's got a lot of good art here, so definitely reach out and hit him up. He does some good chibi art, but he also does some other stuff too. Here's the page that I got. Worked really quickly, really good prices, so shout outs to him for that. It kind of spices it up and gives it some character. And he drew it with glasses and without glasses, so you can pick your flavor right there. All right. We went over these two. Oh yeah, so there's a command that you can run in Linux on a binary called nm, which will give you a list of symbols. So if I run this on here, these are all of the names essentially. That's what a symbol is. It's essentially a name to all the functions and variables in your entire binary, and this is the address where those symbols reside at. So when you're accessing a variable like Raspi, that has the Raspberry Pi version in it, it's at address blah. Or when you want to call this function, it's at this address. So I updated the serial client so it actually pulls in. Let me run this again so you can see. The serial client now has a drop down right here above the bookmarks now with a list of all the symbols in it. Let's make sure that memory is working. Yes, it is. So here we go. Boom, everything. So if we wanted to see what the data for the Kitsune logo looks like, we could go to binary logo data start. And here we've got the width and the height in little Indian binary right there. That's appended to the front of the image, and then a bunch of zeros just because it's all transparent bits and bytes. And let's see how far down we have to go to actually. There we go. There's the very tip of the ears. And then we go down a little further and see there's more. And so you start to see more and more data as we go further down because it's just scanning. And then we can even see the beginning of the data section. So data start. Oh, no, not data. Let's do read only. Yeah, so here's a lot. See, you can really see over here like a lot of recognizable stuff. This is a string that I use to convert binary into hex strings, device tree labels. Most of your strings are in read-only data start. All that stuff. Eventually, I want to be able to disassemble code here live in the serial client UI. So like you could go to, let me go to draw logo, and then this is literally the draw logo function like right here. But you can't really tell because all we're seeing is the hex and the ASCII representation of it. So eventually you'll be able to maybe have some editor down below or something where it'll disassemble this. You can pick, I want it to be able to, you can pick a range of data and then view that data in various formats, either assembly or string or different structures. So that's coming down the pipeline someday. And then the last thing is, I know that a lot of people don't want to mess around with having to build and worry about having to get everything set up. And a lot of you probably even aren't on Linux machines or Mac. You might be on Windows, which, I haven't really set up or tested the build for this yet. So I've got new tools that allow you to either, if you are running Linux, you can run this new tool, the README. Goes into detail about, where is that? I thought I had it in here somewhere. Building. Oh yeah, build the Kitsune SD card image. You just call tools build SD card image, and it will pop a image file right in the root of your directory. So. And so what it's doing right now, it's going to download a full Raspbian Linux image. And then what it'll do is it'll build the kernel, copy the kernel into that image, and it'll strip out the Linux partition on it, which will make for a smaller image, which will make it easier to copy over. Once it's done, you can run this command in Linux, or you might be able to use Rufus on Windows, although I have not tested that yet, so please do that with caution. But this should save people who want to run it on actual hardware some steps. And I forgot to run it in sudo, because on Linux it has to, mount drives and other stuff like that on the file system. So I'll let that run. But yeah, I will upload a release to GitHub with the SD card image before I post this video. So you should be able to go to GitHub and go to the Kitsune AOS project. Link is in the description, and get and download the image, and then you can, if you're able enough, you can plug in an SD card in your computer, copy it on there, and then throw that SD card into your Raspberry Pi, and hopefully it'll work on hardware. Please let me know if any of you want to try this out, even if it's on your emulator, on your computer, or on actual hardware. If you run into problems, please feel free to reach out to me. I'd love to walk you through it so that other people can easily get this up and running on their computers or on the actual hardware. So that's the update for November. Things coming down the pipe. So the next thing I wanted to do, I had that little Mascot, so I was going to just make a very basic kind of roguelike game just to make something more interactive, because so far it's just been a screen with some basic stuff drawn to it. But I decided before I did that, I really wanted the OS to be able to support native keyboard and mouse. Like, you should be able to plug in a USB keyboard and mouse and be able to actually interact with the Raspberry Pi without having to hook into the serial port, which I imagine not a lot of people are going to do. They're not going to take wires and solder a UART chip, USB hub onto their things. So once we get USB and mouse support working, that'll allow pretty much anybody to be able to run it on actual hardware and actually be able to interact with it. The biggest obstacle to that is I have no idea how USB works. I know where the device is in memory, but I have no idea how to write a driver for it. So I've got the Raspberry Linux kernel source here, and I've just started looking through Linux kernel code drivers for USB. So I imagine that'll take me a bit to figure out, even to get something up basic. But we'll see. Honestly, I'm excited about it. Should be fun. Last thing I wanted to mention is I created a Redbubble account, so I'm selling stickers of the temporary Mascot and the Kitsune AOS logo. So if you guys want to grab those are on Redbubble. Under Game Dev Fox is my username if you want to find my shop. Enjoy.